Recording off. किया गया, थोड़ा करना भी पड़ा लेकिन
Hello everyone, how are you all?
fine sir.
And how was the exam?
कंप्लीट हो गया है।
सबका?
नहीं मेरा, कुछ लोग बाकी है, 8-10 लोगों का हो गया शायद।
How many people are left with the interviews? How many people are left?
5-6 जने एक दिन हुआ था, आज 6 जनों का हुआ, 12 जनों का हुआ टोटल।
Okay. Who have given
12-13
today?
जनों का।
Who have given today?
साहिल सर और केशव सर और एक और थे।
Suraj, how was it?
सर मुझे भी देना है मतलब सर।
अच्छा, आज किन्होंने दिया? Who has given today?
आज मेरा था।
कैसा हुआ?
अच्छा था।
That's good. क्या क्या पूछा?
पहले तो 2 क्वेश्चंस तो इसी में के ले लिए थे।
Okay.
अपना टेस्ट में के।
Okay.
वही सेम क्वेश्चन दिया और बोला गया कि उसी को सॉल्व करके बताओ।
Okay.
और उसके बाद में वो कंसेप्ट,
अच्छा।
टाइम कॉम्प्लेक्सिटी ऑफ बबल सॉर्ट, और उस कंसेप्ट में एनकैप्सुलेशन, इनहेरिटेंस, पॉलीमॉर्फिज्म क्या
Okay.
होता है, उसके डेफिनेशन क्या क्या है, और उसके बाद में इतना पूछा। और 3 क्वेश्चंस वो पूछे जो इसमें आए थे टेस्ट में, और जो भी क्वेश्चंस हमने सॉल्व किया है उसका ड्राई रन।
That's great. That's great.
कोड अपने सामने है, जो आपने कोड लिखा है उसको ड्राई रन करके बताओ।
ओके फाइन, वेरी
और
गुड।
एक क्वेश्चन दिया था,
ये होना भी चाहिए, ये होना भी चाहिए।
एक क्वेश्चन दिया था उन्होंने, linear search, if element is found in array, print index of the key element, else print -1.
ये तो आसान सा हो गया,
हाँ,
लिनियर सर्च।
linear search। फिर उसके बाद में रिवर्स द नंबर बोला।
ओके, कर दिए।
हाँ, रिवर्स वाला तो इजी है ना। उसके बाद ग्रेडिंग सिस्टम वाला भी पूछा क्वेश्चन, सॉल्व करके बताओ बोले ग्रेडिंग सिस्टम। और ग्रेडिंग सिस्टम वाला आप कुछ कोई और तरीके से सॉल्व कर सकते हो क्या?
ओके, दैट्स गुड। कैसे सॉल्व किया था आज, कौन सा अप्रोच दिखाया?
इफ एल्स।
ओके, गुड। दूसरा अप्रोच होगा हैशिंग बेस्ड। आई थिंक
हैशिंग
कोड हमने दिया है, किनको दिया?
नहीं, कोड नहीं मिला, बट मुझे पता था कि हैशिंग से हो सकता है।
किसको दिया था
तो
उस दिन?
वो डाउट सेशन में लिया था आपने।
तृप्ति को मैंने बताया था हैशिंग बेस्ड अप्रोच। हैशिंग इज द इजीएस्ट अप्रोच टू सॉल्व दिस प्रॉब्लम।
मर्ज सॉर्ट पूछा, मैं बोला मर्ज सॉर्ट मुझे पता है होता क्या है, बट इतना ज्यादा क्लियर नहीं हूँ। तो बोले ठीक है, एक बार रिवाइज कर लेना। लास्ट में पूछा था वो सब कुछ।
ओके ग्रेट। कौन से सर ने लिया था?
साहिल सर।
ग्रेट ग्रेट, चलो बढ़िया, चलो बढ़िया है, बहुत अच्छे। और कौन कौन दिए आज एग्जाम?
लग नहीं रहा था कि क्लियर होगा, बट बाद में जब स्टार्ट हुआ तो ऐसा लग रहा था कि हाँ हो जाएगा।
क्लियर क्यों नहीं होगा, इतना
पता नहीं,
घबराते
आज
हो यार।
आज 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 फर्स्ट टाइम बहुत डर लग रहा था, बहुत ज्यादा।
यार अगर जब आता है हर चीज तो फिर डरते क्यों हो?
नहीं, लास्ट टाइम नहीं लगा मुझे, आज पता नहीं बहुत ज्यादा लग रहा था। ऐसा लग रहा था कि ना दूं तो ठीक है। वो सुबह से माइंडसेट वैसा था ना।
Okay, so tomorrow, yesterday, what problem we have seen, we will code it today. Okay, first we will code it, then we will move on to linked list part. Okay, let's begin today's session. We're already late. Okay, what was the question yesterday? What we were discussing? Q's problem. What we were discussing? What we were discussing yesterday? Given what? Given a stream of characters. Okay, given a stream of characters, one by one I have to take input. One by one I have to take input. Once I've taken the input, I have to print, okay, inside my present stream, inside the present stream, what is the first non-repeating character I have? This is my question, okay? Suppose that this is my stream, first this input will be there, okay? This is the first input, next this input will be coming, next this input will be coming, next this input will be coming, next this. So with each input that I am taking, okay, I have to print which is the first non-repeating character once I have received my present input. Okay, so what approach we have seen? We will maintain a dictionary. We'll maintain a dictionary. Inside the dictionary, I will mark how many times a particular character has occurred, and as well as to maintain the order, in what order these characters have occurred, which have occurred first, which have occurred last, these particular characters. For that I'm maintaining a queue. I'm maintaining a queue. So what we were discussing yesterday, okay, first let's say A is my input. The first character I am receiving is A. Is it inside the dictionary? No. So what I will do, create a key A and mark its presence to be that, okay, once it has once it has occurred inside my present stream, and okay, insert inside the queue A. Insert inside the queue the character A. Now start checking from the front to the rear, from the front to the rear, okay, whether which character has occurred, or which is the first non-repeating character of my present stream. Okay, so I have only one element inside my queue, that is A. Let's check it. It has occurred exactly once inside my queue. Okay, sorry, it has occurred exactly once inside my character stream till now. So what I will do, For this A, till the time for the first input this A, I will print A. This is the first non-repeating character. Fine. Next, let's say I receive B. I receive B. Next character that I get as input is B. What I will do, I will check inside the dictionary any B is there? No. Mark this B that it is present once, and then I will do what? Inside the queue, push this B. Inside the queue, push this B. Why I pushed it? When I will push it? Whenever I have just inserted any new key inside the dictionary, and at that moment, its value for key B is 1. At that moment, I will push inside that. Okay, new key is coming inside my dictionary. For that, okay, for that case, push that character into the queue. I have pushed B. Now start checking from the front to the rear. From the front to the rear, which character is the first non-repeating character in my present string? Okay, so okay, I started from A. Has A occurred exactly once inside the dictionary? Yes. So do what? Print A. Print A. Fine. No need to check anymore because A has occurred first. First non-repeating character I have to check. So first non-repeating character even after B is coming is A only because A has arrived earlier than B. Next, let's say C is coming inside my input. C is coming inside my input string. Okay, fine. So is C present inside the dictionary? Is C present? No. Make a key C and mark its presence to be 1. That okay, C has occurred exactly once inside my stream. This 1 indicates that. And okay, since new key C is getting inserted into the dictionary, insert C into the queue. Fine. Now start checking from the front. Okay, first check this character A. A has occurred exactly once inside the dictionary. The front element, yes. Do what? Print A for this. No need to check any further because A is the first character. A is the first character that has occurred non-repeatedly inside the stream. Okay, now let's say again B arrives. Again B arrives. Fine. So okay, B is already present. Increase its count by 1. That okay, B now has arrived twice inside my stream. B has occurred, so I increase its count by 1 inside the dictionary. Since it is already present, it was already present inside the dictionary, no need to add any new B inside the queue. No need to add. Done. Now start checking from the queue, from the front element of the queue. A has occurred exactly once inside the dictionary. Yes. So again, answer will be A only. Answer for the fourth input also will be A. Now again, let's say A arrives. Now A character arrives again. Okay, fine. A has already been there inside the dictionary. Increase its count by 1. Increase its count by 1. Done. Next, what will I do? Since A was already there present inside the dictionary, no need to insert it in, push it into the, sorry, no need to insert it into the queue anymore. Okay. Now start checking from the front. Okay, value of A, frequency of A into the stream, is it equal to 1? No, it is 2, right? It is 2. So do what? Pop it out. Remove the front from the queue. Removed. Okay, done. My new front is what? B. My new front is B. Now see, is B present once inside my stream? Inside my present stream, is B present exactly once? No. Okay, pop. Remove it. Remove it out. Remove the front from the queue, and new front moves to this last character C. Again, check this C. Is this C present exactly once inside my current stream? Yes, it is exactly once. So answer for my fifth input is C. That first non-repeating character after receiving the second A is C. Done. So how to code it? We will see it now. Okay. Tell me, is the approach clear to all of you? Please tell.
Yes, so clear.
Only one. Rest.
सर एक बार और रिपीट कर दीजिए सर.
Okay. क्या हो गया यार? Whatever. See here, I will get infinite stream of characters. Okay, so I have to print. Okay, let's say A is coming, then B came, then C came, then D came. After receiving each input of the stream, I have to print which is the first non-repeating character. A has arrived. Let's say first character that I am receiving, first character that I have received is A. First character I have received is A. What is, so till now my stream is A only. Stream has only one character only. What is the first non-repeating character I have? A. Next, suppose B comes. Two characters are inside my present stream now. What is the first non-repeating character? Again A. Again A. Now let's suppose C comes. What is the first non-repeating character in my present stream? A. Now let's suppose again B comes. Yet again, what is the first non-repeating character I have? A, right? A has occurred earliest and it has occurred exactly once. So what is it? How many? What will I say? What is the first non-repeating character I have inside my present stream? A. At the end, let's say again, after this B, A arrives. Fine. So what is the first non-repeating character that I have inside my stream? Who will say? A, B, C, B, A. What is the first non-repeating character inside the stream I have? C.
So C.
Correct? Okay. So how will we do that? How will we do that? How will we judge? We will use two techniques here. One is hashing. Another is hashing and another is queues. This is a question that is related to hashing plus queues.
Sir, is that hash map?
Yeah, hashing means utilizing dictionaries.
Okay.
Okay, dictionaries are a implementation of hash maps in Python. Getting it?
Yeah.
Hash maps is a generic data structure. How we implement it in Python using dictionaries. Done.
Yeah.
See now what will happen. Okay, first character. This is my dictionary. This is my dictionary, and this is initially my queue is empty. Receive the first character as input. Okay, is it present inside the dictionary? No. Insert the key as A. Mark its value to be 1. Okay, that character A is present exactly once inside my queue, inside my present stream now. Okay, so since A was not present inside the dictionary, what will we do? Insert the character inside the queue. Now start iterating over the queue. Start iterating over the queue from the front to the rear. Getting it? So right now inside my queue, front is also here, rear is also here. From the front to the rear, I will iterate. I will check. Okay, see, is the front element occurring exactly once inside the dictionary? That is A1. What does it mean? Character A has occurred exactly once inside the stream. So what is the frequency of A inside the stream? 1. So is the front element occurring exactly once inside the stream? I will check the dictionary. Answer is yes. Print A. Print A. Now let's say I receive another character B. Is B present inside the dictionary? No. So mark its presence. Insert key B and its value to be 1. That B has occurred exactly once inside my stream. Fine. Okay. Since B was not earlier present, insert that into the queue, and now my rear will be pointing here at this B. Fine. Now see. Okay, fine. Now start iterating from A to B. From front to the rear, start iterating. Again, see. Is A occurring exactly once inside my stream? Is it true? How will I check? I will check the dictionary. What is the value of my key A that I have? 1. That means it has occurred exactly once inside my stream. So do what? Print A. Print A. First element I have to print, that is non-repeating in nature. Again, let's say after this, C arrives. C arrives. C present inside the dictionary? No. Insert the key as C, mark its value to be 1. I can do. C is not present inside the queue also. Insert element C inside the queue. Front is at A, C is at the rear. Fine. Now see, again start iterating the queue from front to the rear. First check, is A occurring exactly once inside the stream? Yes. How will I check? Check the value inside value of key A inside the dictionary. It is equal to 1. Print A. No need to check anything else because A is the first element. Okay, is the first element. The order A, B, C, B has occurred after one, after A, C has occurred after both B and A. Okay, how I am maintaining that? I have one by one pushed them into the queue. Queue data structure will maintain the order. That okay, if A has occurred earlier inside the stream, A will be occurring earlier inside the queue also. Then B will be coming, then C will be coming. Key will be maintaining that. Fine. Now let's say again a B is coming. After this C, again a B is coming. Okay, is B already present inside the dictionary? No. Sorry, yeah, it is present, right? B is already present. Increase the count. How many times it has occurred? 2 times. Increase the count. Inside the stream, it is occurring 2 times. So do what now? Again start. No need to, since B was already present inside my dictionary, no need to add any B, no need to insert any character B inside my queue. Just start iterating. Is A from the front to the rear? Start iterating. Is A the first character? Let's see. Is A occurring exactly once inside the dictionary? True or false? True. That means it has occurred exactly once inside the stream. So print A for this also. No need to check any more character. Okay, now let's say again A comes here. A comes here. After this B, A is coming. So now A is already present inside the dictionary. Mark, increase the value. Increase its value. Okay, A was already present inside the dictionary. No need to insert character A inside my queue again. No need to do that. It is already there. Why should I do? Now start checking from the front. A has occurred exactly once inside my stream. Check its value, check the value of key A inside the dictionary. What is the value? 2. That means it has occurred twice inside my stream. So do what? Pop this character A. Why? Because A cannot be the answer in future also. Pop it out. No need to keep it inside my queue. Okay, now front shift to B. Has B occurred exactly once inside my stream? No, it has occurred twice. See, its value inside the dictionary is twice. Pop it out. No need to keep it anymore. Why should I keep? It cannot be the answer anyhow. Now front shifts to this C. Front of the queue shifts to C. Now check. Has C occurred exactly once inside my dictionary? Has it occurred? Yes. So answer for this A is C. Getting it? How will we do it? How will we do it? Is it clear now? Is it clear now? Please tell me. Shall I go ahead with the coding part? So what I have to maintain a dictionary and another thing. What else I have to do? Queue, right? I have to maintain a queue also. Okay, fine. Let's copy paste our push and pop. Sorry, NQ and DQ operations from here. Let's copy paste it. Fine. This part is done. Okay, now there is an infinite sequence. Okay, let's say I have to stop taking the input. I will stop taking the input when finally I will receive an input called -1. After this A, let's suppose -1 is arrived. So I will stop taking the input from here. Something like that I have to do. Okay, fine. Let's do something. Let's say not. Let's don't take it as -1. Let's take it as 0. Whenever I will receive an input called 0, that marks that okay, input stream stops here, and I don't need to make any more inputs. I don't need to take. Fine. So how will I do in such case? What will I do in such case? So, okay, let's keep one condition, while true. What will happen here? Anybody can tell? While true. While true, do what? Do one thing. Take an input. What is it? Let's take a character input. Taken. Okay, if I'm taking input as from this input function, it will be by default. By default, it will be what? A string. So I have to first check. Okay, if c equals to 0, do what? Break the loop from here. No more inputs will be there. This part is done. Okay. Else what will I do? Okay, first check. If c in dictionary.keys, if c is present in dictionary.keys, what will I do? I will simply
Count, increase the.
okay, let's not do it like this, but yeah, if c is not present in dictionary.keys, what I have to do? I have to mark something like this, right?
Dictionary dot account.
Dictionary of, let's insert a key, character key c, and that its value will be what? 1. Okay, that okay. New key is coming inside my dictionary and its value is 1. Fine. Else do what? Else if it is already present inside my dictionary, what I have to do? Dictionary of c, increase its value to be 1. Done. And what else I have to do? One thing we have missed here. If it is not present inside the dictionary, what I have to do? I have to perform enqueue operation. Am I correct? Enqueue what? Enqueue q. Enqueue inside the queue character c. Done. This part is done. Now next, what will I do? I will start checking from the front to the rear, right? So, okay, what condition we have discussed yesterday? Okay, that if no character is there, let's suppose I have a stream. I have taken this amount of input. I have taken 6 inputs and I'm standing here. Which character is non-repeating?
Nothing.
With nothing, right? So in this case, I will be printing -1. Am I correct? This is what we are. In this case, I will be printing -1. So see, what will happen in these cases? My queue will be empty. In these cases, my queue will be empty. How will I judge that? So at first, let me check if length of my queue, if this is 0, print -1. Okay, yeah, let's not do it first. Let's not do it first. Let's rather first traverse my queue, whatever is the content, while, okay, now the traversal part is coming, that from front to the rear, I have to go. How shall I do that? What do you think? From front to the rear, I have to go on checking one by one. That okay, which element I am getting that is non-repeating in nature. What I was doing, where is it? Let's suppose my queue was this ABC. What was the last case we have seen? A was present twice, B was present also twice, C was present once, right? So what I was checking, if the front element that I have inside my queue occurs exactly once or not. Am I correct? If it is not, pop it out from the queue. So what we can do here is while how will we know what is the front element? While q of 0, this is my front element, I can indicate, or you can define a separate function for this. We'll see that later on, or let us define. Okay, let us define.
So can't we DQ at else part?
Which part?
So else part, if else part last.
We have to
Where-
maintain the order, right? We have to maintain the order. If you do it there, character may be anything, right? What we did here, A, B, C, B. This was my sequence when actually my dictionary was looking something like this. B was twice and C was once, right? So for dequeuing purpose, I have to start from the front. A will also be, what was my queue here? How was my queue looking like? A, B, and C. I have to, if I want to dequeue, what I have to do? I have to remove A also. I have to remove B also. Even after removing this A, then only B can be removed. This is the nature of dequeue operation in queues. So A is my answer for this case. How can I remove this A? Okay, so till the time there is a possibility that A can be my answer. Let the queue be like this, no problem. Okay, let the queue be like this, no problem at all. So let's define a method where we will find the front element. Okay, while define front, and what it takes queue here. What it will be? Return queue of 0, nothing else. The first element of the queue. Fine, let's see. So what I can say, while front of queue is an element that I am getting. So inside the dictionary, while inside the dictionary, front of queue has occurred more than once, and length of queue is not empty. Length of queue is greater than 0. Do what? DQ, perform DQ operation. Perform DQ over the queue. This part is done. Now after this I will check. Okay, if length of the queue, if this is coming to be 0, print -1. Print -1. Else print front of the queue. Okay. Anything else I require here to do? What do you think? Anything else I require here to do? Okay. So let's do one thing. Yeah. Let's run it. PyTest.py. Okay, yeah. What is happening, man? Sorry, it's not saved. Yeah. Which character you want to give? Tell me. Which character you want to give as the input? Somebody tell me which character you want to give. Let's start with A. Okay, given A, answer is A. Then B, again answer is A. Then C, again answer is A. Then let's suppose B again answer is A. Let's suppose A again, answer is C. Am I getting the correct result? Then again, if I give C, what is happening? Okay. Test.py front list out of range. Where it had happened? Length of queue. Okay, fine. Yeah, man. What's the issue here? One condition should be false here. Why is it not taking that? Okay, sorry. Let's make it first. Let's keep it first here. And then let me keep this. Now let me run it again. Let me keep A here. Okay. Okay, fine. Completely fine. Working. No problem. Let me run. Somebody give me a sequence. Who want to give me a sequence? You make a sequence in mind. Somebody give it. Let's try on your input. Okay, given A here first. What should be my answer? Okay, let's take Ibrar's. Let's take Ibrar's input here. Okay. What is it? A, B, B, C, C, D, D. Okay. E, F, G, G, H, H. This is a quite long input. Okay, let me try with the Tintu's one. A, B, C, A, B, B. Okay. What should be the expected output for that? For A will be the answer. For this B, A will be the answer. For this C, A will be the answer. Again, next B will be the answer. B will be the answer.
B will be the answer.
C will be the answer. C will be the answer. Let's see whether we are getting it or not. Okay. First character is A is the answer. Correct. Next character is B. A is the answer. Next character is C. A is the answer. Next character is A. B is the answer. Next character is A. P is the answer. Next character is B. C is the answer. Next character is B. C is the answer. Now let's stop our input here by 0. Done. Getting the correct answer by this logic.
So also bring -1.
Yeah, okay, fine. So after this B, let's say we have 1C also. Okay, now somebody has given an input. A, B, C, B, A. Okay. And let's include here C, another C, and D, F, G. Fine. Then let's see what should be my input. Py test.py. Fine. See, what is the first character? A. A is my answer. Okay. Then B. A is my answer. Then C. A is my answer. Then next B. A is my answer. Fine. Then let me give A. C is my answer. Then let me give C. -1 is my answer. Fine. Then let me give D. D is my answer. Then let me give F. D is my answer. Let me give G. D is my answer. Okay. Okay. Am I getting it correctly? Am I getting it correctly? A for A, then again A, then again A. Next. Okay. Okay. So let's do one thing. In front of the queue. So print here first. The answer is okay. Print here first. The answer is, and let me give the separator as space. Now let me do it. Okay, Control C. Let me go out of it. Okay, yeah. Then let's see. First is what? Okay, let me first write the answer for this particular input. I have A, and this for B. Again, A will be the answer. Am I correct? For this, once A is coming, C will be the answer. For this, -1. For this D, for this F, for this, sorry, for this D, for this also D. This will be my expected answer. Okay, let's try giving this. First character A. Answer is A. Am I correct? Next character is B. Answer is A. Correct. Next character is C. Answer is A. Correct. Next character is B. Answer is A. Correct. Next character is A. Answer is C. Correct. Next character is C. Answer is -1. Correct. Character is D, answer is D. Character is F, answer is D. And character is G, answer is D. All correct. Now let me end my input by giving a 0. Done.
So -1 is printing when the array is empty, right?
When my stream is still here.
No, queued.
When my stream is still here, all have occurred twice. A has occurred twice, B has occurred twice, C has occurred twice. So no character here is
No.
non-repeating. So for that case, -1 we are printing.
Okay.
Okay. Fine. Tell me, this question is clear? This question is clear how we have implemented and all?
Yes, sir.
Sure. This is one of the best questions of queues that I have seen. Best questions. More application of queues you will see when we will go to the topic graphs. Few days are left for graphs. Any doubt you are having? Please ask. Any doubt you're having, please ask. Which code you want? Okay, let's have a small walkthrough. Okay, small walkthrough. Let me have the input as ABCB, correct? ABCB, let me have this input. Okay, initially I have, okay, these are my NQ, DQ and front operations. Fine. Dictionary is initially empty. Dictionary is initially empty. And Q is also empty, correct? Let's go inside the loop now. Let's go inside the loop. While true. This is a condition for while loop will be running infinite times till the time I break it. While loop will be running infinite times till the time I break it. I have to break it myself. It will not terminate on its own. I have given condition here that, okay, the condition will always be true. Run, keep on running till the time I tell you to break. Okay, because I have been told that I have to take infinite stream of input till the time I receive a 0. This is my question. Okay, fine. Let's come inside the loop now. Okay, first, let us take C is equal to, this is my stream, let's say, getting my first character as A. Okay, C is what? A, the string A, let's say. Okay, now, is this first condition inside the loop? Is this C equal to 0? Is it equal to 0? False. Go, skip this condition, go to the next condition. C not in dictionary.keys. Is this true? Character A not present in dictionary.keys. Is this true?
Yes, true.
Do what? Insert a character C, insert whatever is the content inside variable C, insert that as a key and mark its value to be 1. Done. Done. And then perform the NQ operation. Inside the queue, insert whatever is stored inside variable C. Done that. Done that. Next. Okay, next come to this condition. While length of the queue is greater than 0. Length of the queue is greater than 0. Is it true? True or false? Length of the queue is greater than 0.
True.
True. Dictionary front of, what is the front of the queue I have right now? A.
A.
Dictionary. Inside the dictionary, value of this A, is it greater than 1? Is it greater than 1?
No, false.
False, right? So do what? So this loop, so what is happening?
Terminate.
True and false, true and false. What is the final result? False.
False.
So this loop doesn't execute. This loop doesn't execute. And then what? Print. First, the answer is printing, and then, okay, let me go one step down. Okay, then again check the condition. Length of the queue, is it equal to 0? No, it's not equal to 0. What is it rather? Length of the queue is 1. One character is present inside my queue. So do what? Skip this condition, print the front of the queue. What result I am getting? A. Print the front of the queue. A. Done. Okay, now let's say next character B is arriving. Next character B is arriving. Fine. Next character B is arriving. So this was a part of the while loop. Go back to the while loop. B has arrived, go back to the while loop. It is true. Keep on executing. So what will be the next content I will be having when B arrives? C equal to input. What will be the content of C? B. Correct. Okay, if C equal to 0, is this B equal to 0? False. Come here. C not in dictionary.keys. True. Content of C, that is B. Is this character B not present inside the dictionary? True. Insert that into the dictionary. Dictionary of C equal to 1. And NQ character, whatever is the content of variable C, NQ that inside the queue. Okay, inside the queue, NQ that. Just let me write it. Let's see, queue is here. NQ, B inside the queue. Front is here now, rear is here. Rear is here. Correct. This part is done. Now again, what I have to do? Come here. While length of queue is greater than 0. Is this true? Length of queue is 2. This condition is true. Dictionary of front. Is it greater than 1? Dictionary value of front, of the front character of the queue. Is it equal? Is it greater than 1? False. So skip this condition. Skip this condition. Okay, skip this condition. Skip this loop rather. And then, okay, yeah, this condition will be executed. Answer. Okay, I will check. If length of queue equal to 0, is it equal to 0? Is the length of the queue equal to 0? False. Print the else. Print the front of the queue. Answer is A. Getting it? Now let's say next character is again A. Next character is again A that is coming. Okay, let's go back to the loop. Let's go back to the loop. What input I will be having? What input I will be having? Next character is A. So what will be taken inside C? What will be stored inside C? A. Okay, again, C equal to 0, false. Come here. C not in dictionary.keys. Is this condition true? C, value of C that I have, not in the dictionaries. Is this condition true?
False.
False. So come to the else part now. Dictionary of C, whatever value this C variable is storing, inside the dictionary, increase its value by 1. Done. Okay, now see, while length of Q is greater than 0, this condition is true. Q is having 2 characters. Now, and dictionary value for the front element of the Q is greater than 1. Is this condition true?
True.
Front element is A, its dictionary value is 2, and length of the queue is also greater than 0. So this condition is also true. True and true, what are they? True and true. What is the final result?
True.
So while loop will execute now, right? While loop will execute, DQQ, whatever is the front of element of the queue, remove that. Done. Front comes here. Front comes here. It will go back to the while loop again. Length of the queue greater than 0. This is again true, but here dictionary value for the front of the queue, is it greater than 1? What is the front? Current front I am having B. Dictionary value for the front element, is it greater than 1? No. It is equal to 1, right? So now this becomes false. Now let's move down and see what is the next thing to be done. Okay, this part is done. Check here. Length of the queue is 0? No. Else, execute the else word, print the front of the queue. What is the front? B. Print that. Now let's say again, new character B is coming. So let's go back to the loop. Let's go back to the loop. Where is it? Let's go back to the loop. Last new character that I receive as my input is B. So now value of C changes to B, let's say. Fine. Value of C changes to B, character B. C is equal to 0. Is it true? Is it true? No, false. Okay, now C not in dictionary.keys. Value of C, that is character B, not in dictionary.keys. Is this also true? False. B is present as one of the keys of dictionary, right? Execute the else part. Dictionary, okay, whatever the keys I am having inside C, whatever value of C I have, increment its value inside the dictionary by 1. So it is also now 2. Am I correct? Now check, come to the while loop. Length of queue greater than, what is my queue I am having, current queue? That is B. Front is also here, rear is also here. Length of the queue greater than 0. True. Dictionary value for the front element of the queue, is it greater than 1? Is it greater than 1? What is the queue, front of the queue? B. What is the dictionary value it is having? 2. Greater than 1. So both are true. Execute the loop, dequeue the front element from the queue, dequeue it, remove it. Now the queue is empty. It will go back and now it will check the condition. Length of the queue is greater than 0. No. Now queue is having no elements, its length is 0. So do what? This condition becomes false. While loop does not execute anymore. Fine. Okay, fine. Now check length of the queue. If length of the queue is 0, is it true? Length of the queue equals to 0. Is it true? No elements inside my queue. True. Print -1. That's all. Now, if I go back to the loop now, from this condition, go back to the loop. Let's take an input to be 0. Let's take an input to be 0. C becomes 0. Value of C becomes 0. Now it will check if C equal to 0. True. Break the loop. Break the loop. Everything will stop now. All of you understood this? What we have done? How we have solved this problem? All understood? Tell me that. Any doubt you are having? Shall I move ahead? What shall I do? Tell me. Okay, so let's start with a new topic today, that is linked lists. Okay. So this is a very important topic. Now you are going to step somewhere, which is a transition point, I will say. Till now, everything was simple. Now you are going to something, what I call as transition point. Okay, linked list. data is a data structure. Okay, from here you will learn something complex. This part is not an easier part, and as well as this data structure is very much necessary to understand our upcoming data structures. What are they? Graphs, trees, BST, all these things. If you want to understand in a better manner, this linked list will be very handy data structure. Okay. See what happens in linked list. Linked list is a data structure. Fine. What kind of data structure? What kind of data structure is it? Linear. Can anybody tell me what is a linear data structure? What is a linear data structure? Who will tell? I think we have discussed it twice. Linked list is a linear data structure. What do you mean by that? What do you mean by that? Code, is it that? Data is stored. Data is stored in memory slots one after the another. Data is stored in such a manner such that they occur one after the another. Okay, this is how this is how data I keep. 2, now 3 will be coming after 2. 3, once I take as my data, 4 will be coming after 3. Once I store 4, 5 will be coming after the 4. Again, if I want to store another data after this 5, I can store that. After the 6, I can store another data. In a straight line, what I say, in a straight line arrangement, I can arrange my data. So this is what we call as linear data structures. Linear data structures. Now, what is different with linked list? What is different with linked list? Earlier, we had some kind of convention that, okay, last element will be top, or the first element will be front and the last element will be rear. Okay, how linked lists are different? See, along with data will always be there. 2, 3, 4, 5, 6, 7. Data is there. This data is connected to its next element by something called as pointer. 3 is connected to its next element by something called as pointer. 4 is connected to the next element by something called as pointer. Or a link. Pointer is what? Link. That, okay, this particular 4 is linked to this particular element 5. Without utilizing this link, okay, I cannot go from 4 to 5. This is the analogy for linked list. Without utilizing the link that 4 provides me, I cannot go to the element 5. And as well as there is no concept of indexing. That, okay, this element is at index 0, 1, 2. No such kind of concepts are there inside linked list. Okay. First element is connected to the second element by a link. Okay, called as pointer. Second element is connected to the third element by something called as link or pointer. Similarly, this structure goes on till the last element. Okay, this connectivity goes on till the last element. Okay, and the last element points to somewhere called none. None is a keyword of Python. None is a keyword of Python, which means, okay, this last element points to nowhere, nothing, no value it points to. This particular link points to nowhere or no memory slots. How do I represent that in Python? By some keyword called none. Okay. Now the first element has a pointer. First element is indicated by a pointer called head. By something called head pointer, we keep track, okay, what is the first element of my linked list? And using this, okay, once I know that, okay, using this head variable, I can access the first element of linked list. Now, from the pointer that I have on the first element that points to element 3, I can access the second element. From the pointer that I have inside the second element, I can access the third element, and so on. So one thing what we keep inside linked list is that something like this structure is made. This is the data part where 4 is stored, and this is the pointer part. Both make something called node, a node structure. This entire thing is necessary to keep the first element, because one thing inside linked list is that first element must point to the second element. Whatever is the second element of my current list that I have, first element must have a pointer to the second element. So inside the first element only, I need to have some space for the pointer. Okay. So what we do, instead of earlier what we used to have, we can keep a list or something else. Now we keep something called nodes. We try to make something called nodes and divide it into two parts. First part is the data part, second part is the pointer part. And this pointer is responsible for keeping a track which element is stored at the second slot. And pointer for the second element, pointer whichever I use for the second element, okay, that will be responsible for keeping a track which is my third element. And the last element points to nowhere, that is none. Okay. So to make something called linked list, we don't use conventional list, variable, array, or anything else. We define something called as nodes. Okay. And divide the entire node into two parts. One is the data part. And next is the pointer part. Pointer part is what? Link to the next element. Okay. Using this link only, I can track what is my next element present. And using the link that I have here for this node, I can keep a track what is the next element of this element. If this is not present, you cannot go here, because there is no concept of indexing. Okay. Tell me now, is this point clear to all of you? Whatever we have discussed till now. Tell me that. Last part is what? We define some other structure called nodes. Okay. Or what we say, we define some other data type. we define some other data type for storing both data and a pointer. We define some other data type, okay, for storing both data and a pointer. So the structure is something like that, okay. This is a data, this is a variable of the data type, this is another variable of the data type, okay. But, or rather what we say, okay, we will take the example and that will be more clear. What we say, we define some other data type for storing structures like this. One at one slot, and I divide it into two parts. At one slot, I will be having the data. Another slot will be having a pointer to the next element. Okay, this is node 1, this is node 1, and this is node 2. First node will be having, first node is always called the head, the start point of my entire linked list. Okay, how I do make the linked list using something, some other structure called nodes. What these nodes have inside it? First part is data, another point is pointer. Another part is pointer. And this pointer is necessary to keep a track that, okay, if I am right now standing at the first element, what is my next element I have? What is the next element that I have? Okay. Pointer does what? Okay, let's see why these things are necessary. Why these things are necessary. Okay, so this is what our memory looks like. Let's suppose this is what our memory looks like. Let's say this part of memory is occupied. This part of memory is also occupied. Okay, I require some memory. I require a memory that fits here, and some part of memory I require from here. Let's say, let's not do like this. Let's suppose this is my memory, okay? This is my memory. And I want this much amount of memory, let's say, this much amount of memory I require to do some operations. Okay. If this is free, this part of memory is not under use right now. This will be allotted to me by the computer. Computer will allot me this. But what if this part is also occupied and it's below, some parts below it is also occupied. Computer has to do something so that it gives me memory from the upper part as well as the below part. It has to give me memory to store my data and do operations in broken manner. Part 1 is this, let's say, and part 2 is this, it has given me. So what I have to do, I have to keep a track, okay, that some of my data is kept here and some of my data is kept at the part 2. Let's say, let me draw it. This one is occupied, let's say, as well as this part is occupied. So here I get some data, here I get some data, and here I want to store some data. Computer gives me this, and I have to keep a track where my second data is stored. So for this, I have to define a pointer. Okay, that at one memory location, I have stored my first data. At what other memory location, if I want to access the second data, what will I do? I will keep a pointer from the first data to the second data. Okay, after accessing data at this memory location, you can just using the pointer, you can go to the second location and can access the data here. Okay, for these purposes, these linked lists are very handy. Data structures. These linked lists are very handy. Why? Because a node, let's say this particular data that I have kept in the form of a node. Node are linked, all the first node is linked to the second node. Second node has linked the third node, something like that. So in whatever area of my memory, I keep my data one by one, I can fetch them. How? Using these links. First memory links where my second memory, first data links where my second data is stored. After utilizing the first data, I can go to the second memory. Second data's memory slot, can access it and do my operations. Again, suppose this second data has linked the third data. I can go access it and do my required operations. How can I do that? Using these pointers or the links that I have. Okay, this is where my linked list are used, come very much handy. Getting some idea? Tell me that, or any doubts you are having. Which part to repeat? Let's suppose I want this much amount of memory I want. Okay, this is my full memory that I have, maximum memory that I have inside my computer. This much amount of memory I require to do my operations. So what is happening? So let's say computer gives me a continuous range of memory. Continuous range of memory it gives me because this is free. But what if this entire range was not free? If it was not free, what I can do? This is also not free, and some part here also is not free. Continuous range I cannot get from the memory, right? If some parts are not free, continuous allotment of memory cannot be there. Not possible by the computer. This part is also not free. This part is also not free. Okay. So what I have to do, I have to take computer's memory, some part from here, some part from here. But so I can keep my data one at this location, and I can keep data 2 at this location. But if I want, just after utilizing data 1, I want to access my data 2, where is it kept? I will get confused, right? Because entire memory is staggered. Some part is here, some part is here. Entire data is staggered. Some part is stored here, some part is stored here. So what I can do is that I can introduce links. Okay, data 1 is stored at this location. Link it with the data 2. Link it with the data 2. That okay, data after utilizing my data 1, using the link that data 1 has to data 2, I can go to this memory location and access data 2 and can do my operations. I can do my required operations. Getting at these situations, linked lists come handy. Okay, no matter at which memory location my data is, if I have link to where my next data is stored, I can access it and do my operations. Getting the point? I may get memory from my computer at any free location. What I will do, I will just link these datas using something called as pointers. This pointer will point to which memory location my next data is stored. Okay, so pointers does what? It stores the address of next data. Okay. Any more doubt you are having? Tell me. Any doubts you are having? Sure. All of you? Shall I move ahead? Tell me if you have any doubt or not. I am standing here because I know this topic is quite complex. Okay, fine. So let me move ahead if nobody's telling anything. Fine, this question is done. Start here with something called as linked lists. Okay, what I said, we define some other data type called as node, and node will be storing what? Node will be storing what? First part is data, another part is called pointer. Which pointer is it? Let's name it as next pointer. Next denotes what is the address? What is the address of the next data node that I have? Okay, data 1 is kept here, data 2 is kept here, and continuous linking will be there. Okay, continuous linking will be there. So okay, for defining this structure, can I have a if this? Okay, I see that. I assume that entire data and next pointer is kept as a one unit. Data and next are kept as one unit. Can I declare them using a class? How many of you agree here? Whatever data will be stored, okay, whatever data I will store that in the form of a node. So I must have a next pointer also inside my node. Can I declare that using a class? How many of you say yes? How many of you say no? Tell me. Have some response. Class is what? Collection of data and methods. So I want to have different kind of data inside this node. Can I utilize a class for that? Class can have inside it multiple forms, multiple variables of different types.
Yes, sir.
Okay, so how will I declare? What is the syntax for a class? What is the syntax for declaration of a class? Class, let's name it node. Okay, what it will have inside it? Let's define a constructor, because every node will be having its own data as well as a pointer, and the values for each value that I will be storing inside each node will be separate, maybe separate for each of the nodes, right? Data I will be storing for, let's suppose, this node 1, and node 2, they may be separate. So it's better to define a constructor and declare this attributes data1 and the next pointer, these attributes as instance attributes rather than class attributes. Okay, let's do that. We have discussed, I think, what is instance and what is class attributes. How many of you remember right now? What will be the first argument for this? If I am to declare a constructor, what will be the first argument?
Self.
Self.
And after self,
Argument.
nothing else is required. Let's say I keep a data. What will be the data? Okay. So, okay, let me define self dot data will be equal to data that will be storing whatever data I will pass. Self dot data will be storing that, and self dot next. Let's say I keep something like this. And that, okay, fine. One thing. Self dot next. Sorry, here. Made a mistake here. Self dot next. Let's say once I create a node, I want to point it nowhere. I want to point it nowhere. So if it is pointing nowhere, how can I indicate that using Python? Keyword none. What keyword? Python has a keyword called none. Done. This part is done. Fine. Okay, successfully have made the data type node. I will be utilizing this to make my linked list. I will be utilizing this to make my linked list. Okay. So yeah, let's make 3 nodes. How can I make 3 nodes? I want to make 3 nodes. How will I make? It's a node 1. I make node 2 I will make, and node 3 I will make. Sorry. How will I make each and every of the node? How will I make nodes? Using this class. Class is what? Class node is the data type. Class node is the data type. Node, these nodes are variables of this data type. How will I? Node, write the class name, and let's say I want to make it with data 1. I want to make another node with data 2. I want to make another node with data 3. Have I done it correctly? Tell me. Is it the way of declaring variables for a data type using classes? Tell me.
Creating an object.
Yeah, exactly. Creating an object using classes. Is it the way? Variables for class data type. Variables for a class data type. These variables are called objects. Am I correct? What data type they have? This class data type, class node data type. So what I have to do to have some data inside this node, what I have to do, write the class name, and it has a constructor inside it that takes only one value data, pass the data. Have I done it correctly? How many of you remember this?
Yes, sir.
Sure. So, okay, how node 1, node 2, how node 1, node 2, and node 3 will be looking like? Who will tell? Node 1 will be looking like how? Inside the data slot, it is storing 1 and it is pointing to none. Am I correct? Once I have made this node 1, it is storing inside it data 1 and it is pointing to none. That is nowhere. If it is pointing to nowhere or to no other node, it is pointing. How do I indicate that? Using keyword none inside Python. Okay. Now, similarly, how node 2 will be looking like? Who will tell? How node 2?
It store the value 2,
Yeah.
then next is none.
Okay. It will store the value 2 and next is none. Very good. Its next is none. Sorry.
So none are pointers that are pointing nowhere.
Yeah. None are values of pointers that points to nowhere. Okay. Or you can say null addresses. Null addresses.
So
That
they
has-
are not linked. The data are not linked.
Yeah, sorry.
So these two datas, these two nodes are not linked between each other.
No, I haven't done any linking, right? I have just made the nodes. How node 3 will be looking like now?
So similarly, store the value 3 and
Yeah,
the
it
next
will
is
have
none.
3 in data and it will be pointing to nowhere. Am I correct? How many
Yes.
of you agree here that, okay, these three till now, till the time I have just created the nodes, they will look like something like this. How many of you agree here? Tell me that. Okay, now suppose I want to say that node 2 will be pointing the pointer. Next pointer of node 2 should point to node 3. Should point to node 3. How will I do that?
Node 2 is equal to node 3.
Is it? Next pointer of node 2. Next pointer of node 2 should point to node 3. So what I can do, node 2 dot next points to where? Node 3. Can I do something like this? And similarly, let us say that node 1 dot next points to node 2. Can I do that? Node 1, its next is now pointing to node 2. Done. And let me now define a variable called head. Let me now define a variable called head. That will be storing where it should point, head.
Node 1.
Where what I said, head is what? Head
Send the
points
first
to where?
element.
Head points to the first element of the linked list. So let's store whatever value we have of node 1 inside head. Done. Okay, fine. Now what I said, from the first element to the last element that I have, I want to print what data I have stored. How will I do that? So let's do one thing. Okay, fine. Let me draw it once more for you. how my node structure is looking like now. One is pointing to the second is pointing to the third, and third is pointing where? None. So okay, my head is here, right? My head is here. Okay, if I am to go, if my head is standing here, I can print one. I can access the data, I can print one. Then using this next, I can go to the next element. Now my head will point here. Now I can print two. Okay, I can using this next, I can go to the third, and my head will point here, and I can print three. Okay, fine. Now after these three, using the next, where can I go? After these three, using the next pointer, where can I go? Where can I go? Nowhere, right? So I can give a condition while my head not equal to none. While my head is not equal to none. Do what? Print head dot data. After printing, head will be moving to its next element. How? Head equal to head dot next. Let's try this and let's see whether we have done everything correct or not. Okay. What is it? Has no attributes. Sorry. It is capital T, right? Every answer is coming correct or wrong? Answer is coming correct. When head reaches to somewhere called none, this loop terminates. This particular loop terminates. That's all. Initially, head was pointing at the first element. Then what had happened? It had printed head dot data. What it will point to? Head dot data. Head is accessing the first element of linked list or first node of the linked list. Then it will print data part, whatever is stored in the data part of this node. Then using this next, I will access the second element. This now, what I have done, head equal to head next. Wherever this next pointer is pointing, take the head variable there. Take the head variable there. Now access the, go back to the loop, access the data using head dot data. Access whatever is present inside the data portion, print that. Now wherever inside this node, wherever the next pointer is pointing, take your head pointer there. Done. Next, go back to the loop. Okay. Next, see. Again, print it. Print 3. Access using head dot data and print 3. Print it. Now wherever your next pointer is taking me to, take the head pointer there. So now it is pointing to none. Head will also point to none. Fine, it will go back. Now see, is it not equal to none? Is it true? Is the condition true? If head is pointing to none, that means value of head is none only. It is pointing to nowhere. So head not equal to none. This condition becomes false. Loop also terminates. Okay, this part is done. Tell me any doubt if you are having. How I have stored the data inside my nodes. How I have linked the nodes among themselves, as well as how have I printed them. Tell me if you have any doubt. Tell me if you are having any doubt. Any doubt? What I required, I have to just do one thing. Declare a separate structure for nodes, and using that nodes, I will be creating the objects, and I will be linking the objects using the next pointer. Anything else is required? Let's not keep it. it like this only. Tell me, is everything clear? Have some responses. How can I know? Have you understood or not? One thing, okay? Don't move the head. Never move the head you have, okay? Create a separate pointer called temp. Create a separate pointer called temp, because this is not a good practice to move the head. Head should always point at the starting location. Okay. So what instead I will do, I will take value of head. Wherever head is pointing, I will take value of it inside some other variable called temp. And this temp I will be moving forward. Okay. This temp I will be moving forward. And I will print the required elements. Similar result, no problem.
Sir, I have a doubt.
Tell me.
Sir, जो आपने 57 और 58 लाइन पे लिखा हुआ है, नोड 2 पॉइंट नेक्स्ट इक्वल्स टू नोड 3. तो ये नोड 3 आप नोड 2 नेक्स्ट में नोड 3 की वैल्यू डाल रहे, तो नोड 3 की वैल्यू क्या हो?
नोड 3 की एड्रेस डाल रहा हूँ, वैल्यू नहीं. ये पूरा है ना.
तो पता कैसे चलेगा कि नोड 3 एड्रेस दे रहा है उसमें?
वेरिएबल में क्या स्टोर हो रहा है? वेरिएबल किसके लिए डिफाइंड है? नोड 3 किसके लिए डिफाइंड है? नोड 3 मेरे एनालॉजी में थर्ड नोड के लिए डिफाइंड है. तो जब भी नोड
वैल्यू डाटा है वो तो 3 है.
ठीक है, पर 3 के साथ कुछ और भी तो है ना. डेटा तो अकेला ना है भाई. डेटा के साथ एक पॉइंटर जरूर होगा, बिकॉज सबका स्ट्रक्चर सेम है. सारे नोड्स का सेम स्ट्रक्चर है. व्हाट इज इट? एवरी डेटा स्लॉट है एज वेल एज अ पॉइंटर है. होना ही है ये. पॉइंटर विल पॉइंट वेयर?
Next value.
To the next node that I have. So I want node 2 dot next. This pointer of node 2 should point to the third node of my linked list. So मैंने इसको link कर दिया. Next will be pointing to node 3. Similarly, node 1 dot next will be pointing to the node 2. This is how I have done the linking. Tell me any doubts you are having. Any doubts?
Repeat it once.
Which one?
The whole part is one more time.
Okay. Okay, so node is a what class? What it will have inside it? Data and the next pointer and the next pointer. Fine. Let's say node 1 equal to node with data 1. If I want to define like this, what will happen? What will happen? Object will be created as node 1. Object is created as node 1 and data in the data part 1 will be stored, and by default I have said okay, self dot next, whatever will be the next pointer of this node 1, set that to none. Done. Similarly, what will I do for node 2? Similarly, for node 2, what will I do? For node 2 object, if I create, I want to store 2 inside its data part. So pass 2. It will, the constructor, what I said, whenever we create an object for a class, its constructor will be called. So its constructor takes an argument data. I have to pass a data here to, I want to store inside the data part of my second node as 2. Okay, fine. So I passed 2, stored it in the data part, and next what will I do? In the next pointer will be pointing to nowhere, none. By default, I have set a value none, so it will be pointing nowhere. Similarly, I will create node 3 that will have data 3 and it will point to none. Fine. All these 3 things are done. Next, come here. Node 2.next equal to node 3. It is node 2. Node 2 is this next pointer. It has a next pointer that points to nowhere initially. But now if I assign it to node 3, this will point to the object node 3. This will store whatever is node 3. You can assume whatever is inside node 3, this pointer can access that. Fine. Now come to the next line, node 1.next. Initially this node 1.next was pointing to none, nowhere. But now I have assigned it. Okay, you can now go and point to whatever is the content of node 2, or you can point to wherever at whatever address this node 2 is stored. This part is done. Now, okay, I am seeing that head equal to node 1, head equal to node 1. Let me create another variable, and this head will be pointing to node 1. Okay, now I create another variable called temp, and that points to wherever my head is pointing. Temp will also point there. Fine. Now let's iterate my temp. While temp is not equal to none, temp is initially at 1. Temp is initially at node 1. Do what? Print its data. Print its data. What I am printing? 1. Print it. Now wherever the next pointer of my first node is pointing, take temp to that address. Take temp to that address. Taken. Again, go back to the loop. Print the data. Temp.data will be 2. Print it. Take my temp variable to that address wherever node 2.next is pointing. Where it will go? Here. Fine. Now go back to the loop. This is a memory slot. Entire node is stored inside some memory. It cannot be none. It cannot be none. That memory address cannot be none, because this node is occupying some memory inside my computer. So temp cannot point. If temp is pointing to a node, it cannot point to somewhere called none. It cannot. Fine. So this condition will, till the time I have any kind of node inside my linked list condition, this condition will always be false. Always be true, sorry. Always be true. Not equal to none, that means it is true. Okay. Now print the temp data. Print 3. Done. Print it. Now temp equal to temp next. Wherever this node 3's next pointer is pointing, take me there. So now temp is coming to an unknown value called none. That temp now points to nowhere. Go back to the loop. Now see, temp not equal to none. Is this condition true anymore? No. So this loop terminates. Finally, I'm getting output as 1, 2, 3. And if I'm using a temp variable, see, head is not changing its place, but rather head is pointing to the first node of my linked list only. It will never change its place.
Temp is the pointer now.
Temp is an extra variable. Yeah, you can assume it to be a pointer. Just like head, temp is also a pointer. Is everything clear? Tell me that. Or any doubt you are having for the linked list part. Okay. Let's do it instead of, let's print temp dot next also. Okay. Let's print it and let's see what we are getting. Getting the addresses, it is pointing to address of 2, it is pointing to address of 3, and 3 is pointing to nowhere called none. Print here, print. Okay. You can check print node 1, print node 2, print node 3. If I do something like this, what result I will get? Okay, yeah, sorry, yeah, what I did. You are getting their addresses. Object add this. See, if the data for the first node data is 1, is it pointing to the same location where node 2 is? Correct? And is node 2 pointing to the same location where node 3 is? Right, they are same, right? And node 3 is pointing where? At no location, that is none. Getting it? Any doubts you are having, tell me, else we will continue tomorrow. Any doubt you can ask. Okay, let's take the MCQs in, then we will wrap up. Let me clear the attendance for all of you first. I have created the attendance. Please mark your attendance, all of you. And let me now create the MCQ. First, I have given first MCQ I have given. Good night, all of you.
सर
Those who don't have any doubt, you can leave.
हेलो
हेलो, बोलो।
सर एरर भेजे आपको क्या?
शेयर करो, शेयर करो। कहाँ पे एरर है? फ्रंट में क्या हुआ है देखो, फ्रंट ऑफ क्यू होगा ना।
कौन सा?
लास्ट लाइन, लास्ट लाइन, एकदम लास्ट लाइन।
ये
फ्रंट और फ्रंट ऑफ क्यू। फ्रंट इज अ फंक्शन, राइट?
बट उसमें फिर वो ऐसे क्यों एरर दिया?
तुम्हारे वहां पे फ्रंट प्रिंट हो रहा है, सिर्फ फंक्शन कॉल कर रहे हो। फ्रंट इज अ फंक्शन, राइट? Front should be passed some arguments as the queue. तब जाके कुछ रिटर्न आएगा वहां से। ओके, हो रहा है?
हो गया।
फाइन। All clear? You have?
नहीं समझा आज का।
क्या हुआ?
नहीं समझा आज का।
क्यों, क्या हुआ?
फिर से देखना पड़ेगा।
ठीक है, अगर कुछ लगे तो कल बताना।
नहीं, क्लियरली कुछ भी नहीं समझा। लिंक लिस्ट कुछ भी नहीं समझा।
क्या प्रॉब्लम आया बताओ?
नहीं समझे ही नहीं। लिंक लिस्ट क्या है वही नहीं समझा।
लिंक स्ट्रक्चर है। नोड्स में डेटा को रिप्रेजेंट करते हैं नोड्स के थ्रू। फर्स्ट डेटा सेकंड डेटा से लिंक्ड है वाया सम पॉइंटर। सिमिलरली सेकंड डेटा थर्ड डेटा से लिंक्ड है वाया सम पॉइंटर। इन दिस स्ट्रक्चर वी मेंटेन लिंक लिस्ट।
बट उसका बेनिफिट क्या है?
बोला तो, अगर मेमोरी स्टैगर्ड है, मेमोरी अगर स्टैगर्ड है तो पॉइंट
उसको यूटिलाइज कैसे करना पड़ेगा?
Yes.
जब तक क्लियर नहीं होगा तब तक वो नहीं समझ में आएगा, इसलिए एक बार वो वीडियो और कल का शायद लेक्चर दो चीज में क्लियर हो जाए।
ओके फाइन, फिर प्रॉब्लम होता है तो बताना।
हम्म,
ठीक है, गुड नाइट ऑल ऑफ यू।
तो बस।